Hi, everybody, friends, partners, visitors. Let me introduce our panelist team. Our partner, Haixing He. He is a sales director from INNOTECH-DRONE company based in France, near to Nantes. My colleague, Dmitriy Predein. He's responsible for sales as well and technical support. And my name is Alexander Lopukhov. I'm business development manager for TOPODRONE. So our event, we gathered according our new achievement, which we did with INNOTECH company. But let me shortly introduce in our solution, which we have right now in our hands. First of all, it's PPK kits for drone and UAV PPK kits. You can observe how it looks. It's our new LiDAR models, LiDAR 200. It's the lightest LiDAR on the market. It's 720 grams only. There are sets of cameras like our new product PT61 with a thermal sensor. It's a new Sony camera LX, which can work with different lenses, and set of lenses like RGB lenses you can connect to the camera, and with easy hand just to replace and attach multispectral solution from another our partner, Agravin company. There are several types of this lens with 6 lenses and with 4 lenses and 2 as well. So it's briefly our model role. Of course, some solution for drone, but not for this webinar. And let's start to discuss what we have done together with INNOTECH.
Okay, I will begin. Hi, everybody. Let's start our today's webinar, the affordable accuracy for the Vtol solutions. Let's proceed to the more detailed overview of the TOPODRONE equipment, which is compatible with the Vtol solutions of INNOTECH drones. So first of all, LiDAR 200 plus. Alex already told you about this LiDAR, but I would like to tell you a bit more. So this LiDAR is the most efficient LiDAR out of the TOPODRONE model line. One of the best advantages of this LiDAR is that the operational altitude is between 120 and 130 meters. And that is one of the most important advantages, which gives you an ability to work with the Vtol, the altitude, besides the scanning frequency, of course. So let's have a look on the LiDAR data, which you may achieve using that type of LiDAR. First of all, what we can see here is the mission, which is planned in a proprietary software for Vtols. On the right side of this slide, we can see the colorized point cloud, and also we can see the profile view of this area. For sure, it's possible to generate the DEM and the DSM files, which is the DSM is right here, including the trees, including some structures and everything else which might be on the surface. And the DEM is just the, let's say, altitude map, the elevation map. So after, we can generate the horizontal altitude lines based on the ground layer of the point cloud. And as we can see here, we can also control our accuracy using the ground control points placed on the area. Let's go further. And of course, the weight of any drone payload is very significant, and it affects the flight time and consequently affects on efficiency of the product and the whole set. So we did our best to decrease this parameter without any loss of functionality of the device. Let's start from the P61 camera. It's the first camera which was developed by the TOPODRONE. We are using the RGB lens. This camera helps us to generate awesome orthomosaics, colorize the point clouds, and for sure it gives us an incredible visualization. Here we have the orthomosaics. Using this camera, we can, as it is visible in here, we can colorize the point clouds, and we can do really huge, we can cover really huge areas per one flight. I would say up to 2.5 square kilometers. And the next camera is the P61 with the multispectral lenses. For sure, we can use not only the RGB lenses, but also interchangeable multispectral lenses, which are provided by our partners, the Agrowing company. We can use it with all of our cameras, P61 and PT61 also. So here we have the raw data from the P61 multispectral camera, and using the proprietary Agrowing software, you can easily separate the specters and create an orthomosaic using only the multispectral data. And here we go, our brand new PT61 camera 3-in-1 solution, which is also compatible with Vtols. So we have two options for the built-in thermal sensor, FLIR boson 320 and FLIR boson 640. We have RGB and multispectral lens options. This camera was designed to be used both on the multirotors and also on Vtols. And let's briefly overview the data. We can see the two orthomosaics, which are generated by using this camera. The top one was generated using the multispectral data, and the bottom one was generated with the thermal sensor data. So here we have a building, a structure, which is visible with good utilization. And the last but not least product from TOPODRONE is the UAV PPK, which generally allows you to use any of the payload which don't have the PPK solution inside. And this thing provides you with an affordable accuracy of the data set. So let's continue with overviewing the integration and the test data. As it is visible here, that is the LiDAR 200 Plus installed in the Skycross gondola. And on the left picture, we can see that, let's say, it's locked and ready. So we can go and process with the survey. So first of all, for sure, we shall prepare the mission. And here we have like 4 lines. It was a small area, not very big. So the 4 lines is like even maybe the overkilling, but still. And after performing this flight, we can generate an orthomosaic, because the first flight was performed using the P61 camera. It was just 23 hectares. The whole flight distance was 446 kilometers, and we were using the 155 GSD ground sample distance. Let's understand what shall we do with LiDAR, because LiDAR post-processing stage contains 2 steps. First of all, it's the LiDAR post-processing with trajectory generation, and after that, the cloud generation. I will not show you the trajectory generation because it's the super one-click solution. You just need to upload all of the data to the TOPODRONE software, and after that, you can click the start button. All of the data which was uploaded will be uploaded to the TOPODRONE server. It's a cloud calculation, and in a couple of minutes, you will see that the trajectory file is already downloading. And after that, we can go to a LiDAR cloud generation. So what shall we do in here? We have the pickup file, which contains the point cloud raw data. We have the trajectory file, which is called track file in here. We can also do the strip alignment if we need, if we want to do so. And for sure, we can pick up from the list the necessary projection and the geoid data. Also, as it is visible in here, the real trajectory of the drone movement is really mixed up. So we have some rounds, we have a takeoff line, we have a landing line. We also were performing the calibration for the IMU, which is the infinity sign in the air. But we don't need that information for the point cloud, because it would be mostly it would be just a trash and the noise. So that's why we can press print tracking here, and that is what we will see. We just need to choose the exact area, our 4 lines, and after that press OK, and after that we can see it in the map mode. After picking up everything that we need and setting all of the parameters, we can go further, press start button, and proceed with the cloud generation. while the software is calculating the data, you have the preview window, and you can check whether the point cloud is being calculated properly, or maybe you forgot to set up something and you have some sort of problems in the point cloud, and you can press, for example, stop or pause the calculation and adjust all of the settings. Let's go further and check the sample from the point cloud. Here we have some sort of small airport, the profile view of the point cloud. Let's turn on the intensity mode, and in this mode we can even see some signs on the airport line, and also we can see the small airplane near the structures. And the most interesting is that we performed some tests for our comparison to understand which point cloud would contain the biggest quantity of the points, because when we are using the Vtol, we cannot use it on the speed as a multi-rotor, for example, like 6 or 7 meters per second. And it is all the time interesting what density per square meter would be in that type of point cloud. So we did the comparison, and the answer is on your screen. On the 80 meters, we have approximate point density of 99 points. On 100 meters of altitude, we have approximate density 88. And on 120, it's only 79 points per square meter. We also shall take into account that the velocity, the speed of the Vtol was approximately 22 meters per second. Here it is. That is the data which you can achieve using the Vtol on the different altitudes on the high speed with the LiDAR 200 plus. And that is the thickness of the point cloud. To tell you the truth, I didn't pick up the smallest thickness, the segment with the smallest thickness, because I checked the point cloud with like 80 meters, 100 meters, and 120 meters of altitude, and I saw that the average result might be less. For example, up to 10 centimeters and even less. But in here we have a small angle of the surface, and by dx we have almost 1 meter. So the thickness of this point cloud, taking into account that it was achieved using the Vtol on the high speed and high altitude, in my opinion, it looks good. It looks maybe not great, but very good, very good. So the software which we are using for the processing of this data is the TOPODRONE post-processing. We have a number of the modules which helps us with processing the data from our P61 camera, from LiDAR solutions. It is also possible to post-process the data from some RTK drones such as Mavic 3 Enterprise, such as, for example, P1 camera, and so on. And of course, we're using the LiDAR 360. Like in my opinion, it's the most powerful software for LiDAR processing on this market at this moment. So thank you very much for your attention. That's it from my side.
Okay, I think it's now my turn. Well, I think Dmitry has talked a lot of our integration and the data set. It's just some compliments of your presentation. I will shortly discuss and make a presentation of our company, as well as the areas of activities. Then I'm going to talk about our integration with our Vtol drones, Skycross. And then I'm going to show a real study case that we have done in Malaysia, a city called Taiping. Well, INNOTECH-DRONE is a company based in France. We are manufacturer of Vtol and multi-rotor drones. Nowadays, we have 3 different sizes of Vtol drones, the 2400, 3400, and 4100, which represent the wingspan. We have also a multi-rotor, but it's mainly for some special project. We are a distributor also for TOPODRONE, MLEAD GNSS, SPH engineering, as well as share UAV oblique camera. We also do some special research and development project. For example, the multi-drone for the rotor-drone for GPR in order to detect the pipeline as well as the nuclear power plant inspection. Well, by talking about our integration, thanks a lot for Alex and Ilya to come to our office. We have spent nearly 1 week together to integrate the P61 and the LiDAR 200 Plus on our drone, both 2400 and 3400. And we have done many flight tests during this period, and we get very good results. For example, this result is the P61. I have used 5 ground control points used as checkpoints. We don't use any GCP, but all points has been used as checkpoints. We got a accuracy of 1 centimeter on X, 4 centimeter on Y, and 7 centimeter on Z. So the result is quite amazing. We are very appreciate the integration that Ilya and Alex has helped us to realize. And then we have delivered 2 drones with TOPODRONE LiDAR in Malaysia. And here is the result. Indeed, we have flown very fast, around 22 meters per second. So it's a really fast speed at a flight height of 100 meters. All the data has been processed in TOPODRONE post-processing software and the LiDAR 360. As we can see in the right side, even with the very dense vegetation, we have still lots of points of the ground, which helps the client to make decisions. Actually, the final client is top planning department, so they can have more information of the ground to know where they should still dig or where they should put some terrain to make some construction. And as we can see, we got better results than what we have in our office. The DX and D1 is quite good in this study case, but we got a little bit less point by square meters. But still, we use this Vtol for large area scanning. So the main idea is to scan as big as possible in a short time. So customer is very satisfied of the result. So a quick conclusion, I think Vtol with the LiDAR 200 Plus is a very efficiency solution because we fly very fast and can cover a very large area. And because of this, it's quite cost effective. The most important, we can integrate nearly all the sensors of TOPODRONE on our drone, like the P61 for photogrammetry, the survey and mapping. The PT61 can be used for industrial inspection and surveillance. The P61 with multiple spectral lenses can be used for precision agriculture. And of course, the LiDAR 200 for many different applications. So very happy to work with TOPODRONE because of many different kind of sensors which can supply different solutions to our clients. Thanks a lot.
Haixing, thank you very much for introduction. Please write your questions if you have some. It's a time for Q&A session, and we will answer. While you write down the questions, let me shortly repeat how it looks from our side. First of all, it was a big professionalism from INNOTECH company. They prepared everything, and it took only 2 days for full integration. It was a really short time period when we install our GNSS receiver, when we attach camera, and when we attach our LiDAR, and after that it started to work. And it's very good that it's not only in-house development. Right now there are several customers who use this type of Vtols with our sensors. And like additional things, I think it's our competitive advantages for INNOTECH and for TOPODRONE as well, that we can you can use our sensor not only with the Vtol. You can dismount it and install for mobile scanning. You may use it with a multi-rotor for special missions, etc., etc., etc. So no limitation for Vtol usage. It's an additional freedom for our customers, and it helps save some budgets.
At least we have two questions, and I think that one is directly to the INNOTECH, and another one also regarding the cost of the Vtol.
Well, for the second question, the cost of Vtol, I think it's better to to contact to me by email. I will share all the information, and you can contact also TOPODRONE and
for LiDARs for the payload. Yeah, for sure.
Yeah, even for the drone, you got the price also.
Yeah, absolutely.
Well, for the first question, it's indeed it's a big discussion from our side. For the new legislation Europe, now it's very strict to fly the Vtol drone. We got two scenarios, the STS-01 and STS-02, but we are now working on STS-02, but we need to add some special devices, and usually it depends on the country also. We are now working for France client because we need to add some emergency devices like cut the engine when there is a problem. So this equipment is sold by Thales in France, and we are now working on that. Otherwise, we need to prepare a SORA before each flight. That means you need to ask, in France it's DSEC, maybe in other European countries it's quite similar. You need to describe the risks and declare the person, the pilot, the drone, and obtain a SORA authorization to fly the drone. So the drone is less than 3 meters. The maximum takeoff weight is 9 kilos, so it's quite easy to get the SORA. But still, you need to ask permission to fly the drone. So that's the first question. I think I hope I explained clearly for the first question.
Okay, while it's a short pause for Haixing, let me read another question. Does sensor requires IMU national already integrated or purchased separately? IMU is integrated in our LiDAR system, so it's ready to be used in the fields. What drone can have the LiDAR payload? Not only DJI series, any custom drones can use it, and not only for LiDAR. It's according for all our sensor as well.
Well, the maximum flight time for the drone is 100 minutes. With the LiDAR 200 plus, it's nearly the maximum payload for the 2400. With this small drone, we can fly 50 minutes, 50. Real flight time, and for 3400 we can fly much longer time, around 1 hour and a half, and this is for the LiDAR.
Does the multispectral camera has downwelling light sensor, DLS sensor? Is it compatible with ground-based measurements? To be honest with you, it's still complaining in the multispectral circles. Does it work or not? For the current model of multispectral, we haven't DLS sensor, but anyway, this type of sensor may be used in a special task. For example, for the current model, we especially created PT61 with a thermal sensor because it was a request from agricultural company who works with the Vtol as well and use multispectral layers and plus thermal layers, and they can check the crop stress and some disease, etc., etc.
Well, next question, is the wind condition affect the drone with the LiDAR payload? Well, to be honest, we have a lot of wind in Malaysia. It's not huge, but a quite strong wind, as well as in Nantes. Nantes is in the west coast in France. We even test our drone in very windy conditions. What I can see is usually we will fly not in the direction of the wind or against the wind. We always fly parallel of the wind. So if the wind is not huge, more than 10 meters per second, we can fly our drone. There's not much influence about the data. If you fly perpendicular with the wind, the data is regular. There's no effect of the wind, but you need to pay attention. You cannot fly against the wind and then with the wind at the back, because in this case you will fly the drone very slow against the wind, and then in another direction the drone will fly very fast, and the data will not be good. So all these tips we are going to explain during the training.
So also I can see the question regarding what about very cold conditions? In cold conditions, you will have decreasing the flight time due to the battery, first of all, but the LiDAR solution itself will work, but you can specify the range. We are not talking about, like, I don't know, -100.
For this question, we do have customers in Canada. They fly at quite cold conditions, and also there are some tips. You need to keep the battery warm, for example, in the car before takeoff. That's very important.
Does LiDAR need P61 to work best? No. It's not. You're not obliged to use P61 with LiDAR if you don't need the colorized point cloud. But if so, it is better. For sure, it is better to use the P61 since it's very efficient camera, and you will perform just 2 flights, one with the LiDAR and another one with the camera. And after that, you would be able to generate the orthomosaic, and you would be able to colorize the point cloud from the LiDAR.
According to question about multispectral camera, have you validated the multispectral camera while mounting on drone at different altitudes with ground hyper or multispectral cam on the ground? We did missions on different altitudes, but we have to know your exact task, what we have to do with the multispectral. And after that, we can do for you some recommendation. Haixing, what about coverage on 100 meter altitude for one mission?
For one mission, 100 meter with 22 meters per second, it's around 140 hectare.
Regarding the M350 with 200 plus and with RTK from the drone, it won't be possible because there is no way to connect the GNSS receiver with the RTK antennas of M300, since it is impossible to use the SDK of DJI in this way. So the way you will use the 200 plus LiDAR in pair with M350, we will connect it to the Skyport connection, the LiDAR 200 plus, and the only thing that would be on the top of the drone is just one PPK antenna, nothing else.
From my point of view, if you have a task to perform for big areas, or you need to cover, big big space, the best solution for you is to switch to Vtol solution. And as I marked above, you can install the same sensor you already bought or used before and can slightly transformate your workflow.
Okay, do you have any question, guys?
If not, I think that we can do short conclusions about our successful integration. Say you big thanks for your attention, for visiting our webinar, and see you on our next webinar with announcing of our new solutions and new products. Thank you very much.
Thank you. Thank you, everyone.
Thanks, everybody.
Bye-bye.
Bye-bye.